So now in this video we're going to look at how you can use capacitors to get a higher voltage than the supply voltage. It's a charge pump circuit, a voltage multiplier, but you do not get an exact multiple of the supply voltage because there is some diode drops, which you can address if you really need to. But in any case, we have the capacitor right here. The negative side of the capacitor, it's polarized, they're larger, so probably use polarized for this, is to the negative side of the power supply right there, ground. And then the positive supply heads to the positive supply. It charges through that diode right there. So it's going to fall short of the 5 volts. And so you can expect somewhere around about 4.4 volts or so. Now, we move that jumper I'm going to use, but you could have a switch. You would use an electronic switch. You know, you could use like a 555, the output switches between high and low. Electrically instead of mechanical movement. But in any case, we move the switch to the positive supply. We have the capacitor charged. That's what's important, to 4.4 volts. And we connect the positive side to 5 volts. At this point, in relationship to ground, coming back there, we will have about 9.4 volts to start off with. As current flows through a load, even the little bit that trickles through the multimeter, which we'll see coming up, means the voltage is going to go down from that point. But we're going to start off with about 9.4 volts, and as it draws current, it's going to go down. Therefore, you don't just do this once. You keep repeatedly going ground and positive supply there to charge the capacitor, and then pump that charge at a higher voltage to a load. So now, here I got the multimeter. This is an auto-ranging meter. I just have to set it to V for voltage. Don't have to do anything else. I don't have to move the red probe or the black probe. I don't have to move the red probe for anything other than high current. We're not measuring high current here, so we don't have to worry. Here's the probe. I got an alligator clip and a jumper. So again, the voltage we're interested in is in relationship to ground right there. So that's what we got, our 0 volt reference point right there. And then this will be the voltage in relationship to that. I'll pull that out of the way. And there you can see we got 12 volts because probably because I had it charged before. I do not think that I got that 12 volts there. There you can see 5. So what I'm going to do is actually discharge the capacitor first. So as long as I don't mess anything up, this was the first circuit that I had there. So there you can see. Now it's going to trickle up a little bit. Current does leak through the diode a little bit over time right there when you don't have voltage changes. You don't have like current flowing through a load or something. But there you can see. We're going to trickle our way up to about 5, but it should have been about probably about 4.4 or so approximately. There you can see voltage went up about 5 volts right there because now we have the voltage of the power supply, 5 volts, and then about 5 volts with the capacitor. So that's coming from positive there. They're in series, and then this is headed through ground, through the multimeter there. The diode is blocking current from going back. So there you can see we had our boosted voltage. So this will top it off. There you can see it's going to go up. You know, it trickled because we don't have a load. And there, now we got about 9.8 volts. So now we're going to improve this. What we're going to do is capture the energy in a different capacitor right there and use a diode to make sure that energy does not go back. So we have this spot here. That's where I'm going to put it. So I'm not sure exactly how far the diode's going to go. So we're going to put it first. Of course, remember, diodes let current through one way. That's when the cathode there, I got a gray band, is more negative, and the anode is more positive. It will let current flow. But you flip polarities, it will not let current flow in the other direction, just in case you're new to diodes. And that's the big secret to this video. We only want current to flow one way, and there we go. So this is also a 100 microfarad capacitor, and you can kind of see that there. It didn't print perfectly, even though it's much smaller than that one, which is kind of interesting. So I got them from different kits, obviously, but there we go. And not sure what voltage we'll start off with. We'll see that now. Also, we do have some voltage loss as you demand current from this. As I said before with the diodes, I wrote a note here that if you use a Schottky diode, they're going to drop less voltage. So be aware of that than these regular silicon based diodes. So again, we got the multimeter. It's auto ranging. I just have to set it to V for voltage. If there's numbers, set it to a number higher than you can expect to measure. Always do that. And then we got the red probe. Again, don't have to move it for anything other than high current. Some meters you'll have to move the red probe, and other meters you may even have to move the black probe, depending on what you're measuring. So again, voltage in relationship to ground. Now we care about the voltage of this capacitor, which I do not know if it already had a charge or not. We'll see. And yeah, that's kind of what we expect, somewhere about 4.4 volts. So we got that diode there, and then that diode there. So a couple diode drops from the positive supply, and as long as this hasn't pumped the current. Now we're not going to get an instant 9.5 or whatever volts right there. We have to charge and pump it a number of times. So again, this is without a real load. The multimeter lets a little bit of current flow through, but hardly none. But in any case, sooner or later we will get almost the full voltage that we had before, as long as we don't really draw current. And looks like you know, it'd be about a diode drop less. So I think we are basically at that point. Of course, if we were switching this digitally, going a lot faster, we would have a little bit more voltage and it would level off. So now that's really about it. I'll just mention one more thing. If you're using like super capacitors or something, a high value capacitor, then you would want to definitely limit current, because you kind of have short circuits along the way with this circuit when the capacitor is not charged very much. So you know, you could add just like a low value resistor between the capacitors and the supply voltage, and you know, as long as it's very low, that'll prevent a dangerous amount of current, but still allow a lot of current to be able to go to a load while you're doing this. So thought I'd mention that. But otherwise, that's about it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.